rule, yeah, that we have on the boat is that while the boat is going, you need to stay seated, yeah. Okay. If for some reason you do have to stand up, please ask me first so I slow down, yeah. We don't like swimmers during the tours, okay? I'm kidding, no one will swim, but you know, stay seated, much better, yeah. Perfect. And perhaps if this side of the boat can go a little bit further, I just need a half a meter here. That's good. Thank you. Okay. It's warm. It was a bit windier in the morning. Now it's really not any wind. All boats on the water. So guys,
Copy.
welcome. In case we forgot already, I'm Philippe, yes? If you have any questions, ask, stop me, interrupt me, okay? It's no problem. Our mission, yeah, the mission of every boat tour with us is to reach the front wall of Fjallsárlón Glacier, the one that you see in the horizon, yeah, majestically under the sun today. It's going to take us more or less 20 minutes to be there. Not because it's so far, it's actually very close. If we go straight, it's very fast. But we're going to play a little bit with the icebergs first, yeah? There's plenty of icebergs, very pretty ones, so we're going to explore a little bit before, yeah? We'll be discussing perhaps glacier formations, icebergs, and a little history of the area. So again, just ask me wherever you've been. I will start with the most obvious, which is that we are in a glacier lagoon. Yeah, this is Fjallsárlón. It's not a lake, it's a glacier lagoon. It means that as Fjallsárlón Glacier shrinks, the lagoon gets bigger. This is a very beautiful place, of course, it's very gorgeous, it's perfectly calm today. But the reality is a bit sad. This is the consequence of global warming. There should be a glacier here. Instead, we are sailing on a boat. I will get back to that later, no? But, you know, there used to be a glacier here instead. Every single iceberg that we will encounter today, here, there, it doesn't matter where, every single iceberg comes from that glacier only. Icebergs, in a general sense, no? Icebergs are born, so to speak, when the front wall of the glacier collapses. That event is called a calving. Yeah, calvings are a natural process, a little bit higher frequency during the summer months, but it happens all the time. Every single iceberg was born that way. So the wall breaks, icebergs go into the water, and once they're in the water, they float, and the wind pushes them around. If the wind pushes from the south, the iceberg will go north. If the wind pushes from the north, the iceberg will go south, and so on. Yeah, they are moving, all of them. They look static, you know, but they are moving. They're floating. They might get stuck. They might get a bit locked sometimes, but off they go when the wind pushes enough. I'm sure you've heard also many times the phrase the tip of the iceberg, no? It's very famous on every language, the tip of the iceberg. It comes from nature, it's not just a saying, it's a reality. The tip of the iceberg, according to science, is always 10%. So what we see today individually, no? Each individual iceberg is floating 10% above the water. It means that below the water there's 90% more of ice. That makes icebergs, you know, in a way of saying a little bit dangerous. No, we've seen Titanic, we know what happens. No, if you go very hard against them. Icebergs are much bigger than they look. That's what I mean. So the bigger the iceberg, the further away we stay, just because we don't know where they are. Every single iceberg has 90% of its body under the water still. So it's very tricky to lose track of where they are, how big they are, where they're standing.
How deep is the lagoon?
The lagoon on average, this particular lagoon is 70 meters deep. That's like 230 feet or something. So it's a deep lagoon for the size. Icebergs can be that deep, definitely. So for example, I'm going to rotate a little bit. I will always try to rotate so everyone sees what I'm talking about. This iceberg over here, the one on my left, I'm pointed with the boat. Just to give you an example, icebergs are melting. Yeah, it's very warm today, but in general, it's warm outside of winter. So icebergs melt. As they melt, they shrink, they lose weight, so to speak. No, they become smaller and smaller and smaller. In order to keep the 10% constant above the water, as they melt, they have to rise just to compensate. Yeah. So if you look at this iceberg, for example, it looks like it's floating a little bit above the water, almost like hovering, no, on the water. This is what happens. The iceberg it's on the water, it loses weight, and then suddenly it decides to rise just to keep afloat 10% above the water. So every single iceberg tends to have these horizontal lines parallel to the water. It's exactly where the water was standing perhaps not so long ago. Yeah. Some icebergs are a bit more clear than others. It's easier to see. This is very easy to see. But some others don't have parallel lines anymore. Maybe the iceberg flipped, so the lines are starting to look a bit in a diagonal way. It's very important to look for these lines because this iceberg is quite stable now. We saw it a lot. We know it's not moving. But if an iceberg has 1, 2, 3, 10, 20 lines, that iceberg is moving a bit too much. So we are not going to get that close to them. Yeah. The lines are a very good way to see what iceberg have been doing lately. You start to see these horizontal lines that I've been talking about. Every single iceberg seems to be lifted a little bit from the water, on one side or the other, perhaps all around the brim. Some icebergs have lines way high up from the water. It means that they were much below and they rising and rising and rising over time. It can be a process that happens over days, over weeks, little by little by little they go up, or it can happen out of nowhere and they flip all of a sudden. Yeah. That's the situation that we obviously want to avoid. We don't want to be next to a flipping iceberg. Cool, but it's not so cool. No, honestly, no, it makes no sense. Sometimes, if the lagoon is still, if the wind is very low for a long time, we sort of identify the same icebergs all over the different days, but they move so fast. So this iceberg tomorrow could be over there. And in this much distance and with that much time having passed on, the iceberg is different, especially under the water. No? Because, I don't know, obviously you notice probably the water is cloudy, it's milky, you don't see through. It's not ocean water, it's very fresh, it's fresh water, pure glacier water, but it's filled with sediment. No? This is what we call glacier flowers, like the one you make bread with. It's filled with sediments that are finer than sand. So even if you try to grab the water, you will see it, but it will leave your hand dry. These are sediments that the glaciers picked up along the way. Those sediments are still inside of the icebergs, and as the icebergs melt away, they go into the water. So the water will always be like this, even though it's good water. Yeah? Don't drink it, of course. Yeah, it's not that type of water. But if you could filter this water, you will get the purest drinking water you see. Straight from the glacier. You may notice these sediments still trapped on the ice. Some of the icebergs have a little bit like dirty patches, like black patches along the way. Some are a bit clearer than others. But most of the sediments are still deep inside of the iceberg. Yeah, there, for example, let me show you. Exactly where I'm pointing with the boat, that way. You see that iceberg has rocks and a gigantic stone on it, actually. Those are a very big example of sediments, but those are glacial deposits as well. These are rocks that the glacier picked up along the way in the mountain. Small stones, pebbles, big rocks, and the boulder over there. No one placed that thing there. It was inside of the iceberg. The iceberg melted away and it came out. Glaciers are glaciers are one of the strongest forces in nature. So it doesn't matter what the mountain is made of, the glacier will break it on its way down. In terms of color, yeah, like the color of the ice, so you all wonder, no? Because we've seen plenty of images online these days of very deep blue icebergs. Some of these icebergs are a bit bluer. Here's a good example. I'm going to approach slowly. You can see that this iceberg in front of us right now, I will put the boat both sides, yeah, so everyone can see. This iceberg over here has the same pattern. It has lifted from the water, first of all, quite a few meters actually. But you can see very clearly that the top is white and the bottom part that used to be underwater is blue, yeah, or bluish. This is because the color of the ice depends on two things mainly. On the density of the ice, so how compact, how dense the iceberg is, and how much oxygen is trapped inside of the ice. So if the iceberg is very deep, very compact, very dense, very compressed on itself, it's likely to be very blue. But when the icebergs are exposed to sunlight, to the wind, to the atmosphere, they crack. They lose density because they expand a little, the air goes inside, and the icebergs get filled with bubbles of air. So when that happens, icebergs turn white, like most of them, yeah? It's not that the iceberg is completely white, it's that the outer layer is white because it's filled with air. If you grab the iceberg and you break it like a stick, the core is blue. The outer layer is white, yeah? That's why the parts of the icebergs that come up from the water, they are normally a bit bluer, yeah? But this is something that keeps changing. There's no iceberg that will stay blue forever. As soon as you put it out in the open air, it will start to turn white. That's why they're so pretty, no? They last very, very little. Ice looks like when it hasn't been oxygenated yet. You can pass it around. There's one more over here. These small chunks of ice don't have any oxygen or very little. You can actually see the bubbles inside. So when an iceberg hasn't, this is quite compact, quite dense, no bubbles, no air, so it looks transparent. You can see through. If this was immense, this type of ice would be blue. If this gets filled with air, it will turn white, yeah? But at this size, it's likely that it's still a bit translucent, yeah? But yeah, this is, you know, pure ice from the glacier. And what was that?
It's a souvenir.
If you want to keep it,
okay.
it may, you know, a late night cocktail perhaps. I'm not sure it will survive, but you can try. These icebergs in general, these ones, that one, no matter which iceberg you are holding it now, it's 400-500 years old, yeah? Because that's how long it takes for a piece of ice to come down all the way from the mountain into the water. You know, it might look like just a piece of ice, but it's actually ancient. But yeah, if you don't want it anymore, you can obviously go back to the water, catch and release. If someone wants to play a bit more, you can find, yeah, you can go back. There you go. So yes, let's get a bit deeper. We'll go a bit more into the lagoon. formations around the lagoon are called moraines. And it's a typical feature of glacier lagoon. Yeah, some of you may know this already. When glaciers grow, which is not happening much more these days anymore, when glaciers grow, as I said, they are one of the strongest forces in nature, so they push, and they push whatever they find. In this case, they carved the lagoon, and they made the hill while pushing. Now that the glacier has retreated, the lagoon gets filled with water, but we can still see the hills, yeah? And actually, for example, right there, that's one of the greatest examples we have. You see that boulder standing on the hill? Right where I'm pointing. There's a big rock. Rocks like that, we cannot move. Humans cannot push that rock. So, for a very long time, science, human, everyone in the planet, you know, when you are walking in a mountain, perhaps hiking, and you come across a gigantic stone that is like, who put this here? No, like no one could have put this here. For a very long time, it was an enigma, it was a mystery. No one knew. We thought it was the flood from the Bible, for example. No, still. Nowadays, we know that the only force capable of putting stones like this in weird places are glaciers. So, by looking at this hill and by looking at those random stones that you see around in the fields, you know that the glacier was here. Yeah. So, for a fact, in this particular location, the glacier was touching this shore. Yeah. These are called erratic boulders, and moraines let us understand the true shape of a glacier. Yeah? So when you visit other lagoons or when you hike in the mountains, if you see things like that, there was a glacier where you're standing. No, it's as I said, it's a bit sad, even though it's very pretty. It's sad. Normally a heartbreaking moment for everyone, so I apologize in advance. This I will slow down for dramatic effect. The lagoon is 75 years old only. Yes? It means that if you were in Iceland in the 1950 sharp, that wall of ice was touching the boats.
Ah, okay.
If you were at the shore, the glacier was here. Yeah? So it's not a discussion about, these days, there's a lot of discussion about everything. But it's not about climate change, yes, or climate change, no. Climate change, yes, it's a natural process, there's no arguing with that. But the problem that we are having these days is not climate change itself, it's the speed of the climate change. Because glaciers have changed throughout history, yeah, even without us. When it's cold, glaciers grow. When it's warm, glaciers go back. That part is natural. 75 years for this is not natural, yeah, it's way too fast. So it's not about stopping climate change, it's about slowing it down so that if the world gets colder, glaciers can grow again. Yeah? At this speed, it's not looking like it. And if they are gone, no, imagine the glacier shrinks, and it disappears. It's not coming back. It's not coming back like winter. It doesn't work that way. What was that?
I don't agree with that.
That they are not coming back, or?
No,
The climate change is what, sorry?
the problem.
It's happening,
real problem
of course.
is we are not ready.
I cannot hear you, I'm so sorry.
We are not ready.
We are not ready. Absolutely, we're not ready. I agree with you, sir, of course.
The point is that.
Yeah, we are not going to do anything about it. Of course. Yeah. But exactly, we are still discussing if it's real or not. That's also part of the issue. Yeah, we're not going to fight it this way, of course. Of course, yeah, we are not. I agree, absolutely. We are definitely not ready. Yeah, next generation. Yeah, exactly. At this point, we are in a moment that either we do something about it or it's almost a lost game. You can actually see turning a moment where the glacier used to stand 75 years ago. that it collapses, it carves the mountain. You need those marks. So this back area, so the last bit towards the glacier. You are probably driving, no, a car, I guess, probably by car, most of you. You've seen other glaciers today coming here, I guess, from the road. Every single glacier you've seen in more or less 100 kilometer radius from here is the same glacier. You're looking at the same glacier system. It's officially called Vatnajökull, and it's the largest in Iceland. It's the largest in Europe outside of the Arctic Circle. And in terms of size, it covers 10% of Iceland alone. It's massive. It's so big that it has a bit of a spider head, so it's bigger than the mountain. It rolls down. So what you see from the road are the outlets, and they are all belonging to Vatnajökull. Yeah, it's one glacier. But there's no glaciers nowadays there. It's a bit of an empty zone. The glacier goes around. Yeah, you didn't see it. But it was nice to see the glacier, yeah, of course. You can start to see a bit more the textures, of course, when they closer and closer. Okay. I'm going to slow down here. We have plenty of time. Before we start with the, with the group photo session, yeah. Before we do that, so that we get some perspective on how big this thing really is. Most of this glacier is still under the water. We don't see it. Right now, this sort of imaginary line that you see that me and my colleague are using, this is the deepest part of the lagoon. It's no longer 70 meters, it's 130, still down, yeah? And the glacier wall goes all the way to the bottom, so there's 130 meters still of glacier under, yeah? That's why we keep this much distance, yeah, just in case. We need as much or more, yeah? Another thing that you can notice is that the leading lines of the glacier are different depending where you watch. If you look at the center of the glacier, this bulky big part a bit on our right side, more or less here where I'm pointing, that area looks very sharp, looks very aggressive. It has blades and towers and very sharp edges. It's because at the center of glacier tongues like this, the glacier pushes the strongest. So the glacier looks aggressive, it's splitting, it's breaking up. But if you look a little bit on the side, more over here, the lines don't point to the water anymore. They are pointing sideways and they look much softer, because the glacier gets locked to the sides and it stretches, yeah? So when you look at glaciers in the future, I mean, you can sort of see how it's moving, what it's trying to do. And if you walk on a glacier with a guide, no, on a tour, you are going to normally walk on the locked side of the glacier, no, just to be safe, because it's actually moving, no? You don't want any problems with that. So yes, welcome officially then to the front of Fjallsárlón, one of the outlets of Vatnajökull. If it's so calm, so if you guys want, we can actually organize a beautiful photo session, yeah, and then we continue. Is that okay?
Sure.
shall we? Are you translating for me? Do you understand me? Yes. We can take turns basically to be in the front. We take a couple pictures and then someone else can go to the front if everyone agrees. It's safe, don't have to worry. Sì, potete, esatto. Sì, un desk. One of the things that happens here that is unique is that Vatnajökull is the home of 7 active volcanoes. Yeah? 7 active volcanoes. Sì. So, 7 active volcanoes. And the main problem with this situation is that the volcanoes are under the glacier. And the glacier is 1 kilometer thick. Yes? So when a volcano erupts under a glacier, what you get is a pressure cooker. Yeah? The volcano wants to erupt, but the glacier doesn't let it. It holds it down. If the volcano is strong enough, it will break the pressure of the glacier. And what you get is a stronger volcano. Yeah? So every time one of these 7 volcanoes has managed somehow to erupt, it's been catastrophic. Yeah? Not today, hopefully. We can keep our fingers crossed. Maybe tomorrow, you know. The problem is that even if one of these volcanoes erupt and you are all the way in Myanmar or something, 2010, you are most from Europe, I guess, most of you. In exactly 2010, one of the volcanoes near Vik again erupted, and the airspace in Europe was blocked for like 2 weeks or something. Yes. Reykjavik was okay. You could fly to Iceland, but you could not fly to Europe. Yeah, so it can affect everywhere. Very fast, actually. The last in this system. In Iceland, the biggest one probably was that one, 2010, then 11, but a bit smaller already. You never know if it's going to be, you know, catastrophic or not. No. But there is always, once every 2 years, there is an eruption. Lately, there is a couple small eruptions in Reykjavik. It's fine, like under control. But again, the biggest issue is when you mix them with glaciers. The one in 2010 had a glacier on the top. The one in Reykjavik doesn't have a glacier, so it's kind of okay. But for example, since you're driving a car, no? You have seen the south coast while you're driving, and you have to agree, I guess, that the south coast looks very empty. It's sand and ocean for like kilometers. There's not a single tree around in the area. Once upon a time, though, the south coast of Iceland was the place to be. It was green, it was farming land, there were forests, fish, horses, sports, communities. You know, imagine the full thing, like a shire. But in the 1362, one of these volcanoes erupted, and it was until the date one of the worst eruptions of the island. 30% of the south population died, either during the eruption or after the eruption. Because, you know, it's not about the lava. They didn't see lava.
The gas.
They saw exactly gases coming out of the mountain that made it hard to breathe. Glacial floods, a lot of water coming out of the mountain, flooding the coast, you know, up to here with water, glacial water. Clouds of ash, the sky goes dark, you cannot farm, your animals die, and so on. In that time, the land and the air got polluted. It was poisonous to be here. So people had to leave, and they came back only 50 years later. No one lived here for half a century because of one volcano. Once again, it may sound hard to believe because it's so far away, but there is actual reports of flying icebergs in the sky. Yeah? The flying icebergs. The volcano was so strong that it took the glacier in the air. So, you know, it's a bit like a movie, but that's what can happen. These volcanoes are super, super strong.
This was in the 13th century.
13th century, 1362. So far away, but still.
I don't remember.
Exactly. It can be quite, you know, quite the end of the world movie. It's very beautiful, but we, you know, science especially doesn't forget that there is 7 active volcanoes. And you may have seen while you're driving, once again, there is a lot of bridges in the south, like small bridges that you cross and it's for one car only. This is because every single summer there is a flood. Some place in this mountain will melt because the volcanoes are active. Maybe they don't erupt, but they move. They generate heat. They generate heat.
Okay, copy.
Yeah. So, you know, it looks very peaceful when it's so nice like this, but it's a bit of a monster, you know, a nature monster. So yes, if you want to take perhaps the last couple pictures, let me know. I can rotate, I can help you a bit. Soon enough we'll go to the land.
That piece of blue they just fall like.
Yeah, likely. It's a bit bluish, and you see the wall also is very blue.
Yeah.
So something broke.
Quindi quando si stacca il galleggia poi
Yeah, sì.
Si ribalta,
Sì,
si
sì.
ribalta.
Esatto, si è rivolto un paio di volte.
Quindi la parte azzurra, la parte invece quella più scura.
Does the lagoon freeze up
Yes,
in the winter?
yes. We sail actually from sometime in April. We start trying. We fight the ice. So April to November, and again by the end of November we cannot reach this far anymore, so we stop. It starts to freeze from the shores first, and the glacier also starts to freeze like this. So at some point you are starting to reach further and further and further, and it's like, you know, where's the glacier? So we don't go anymore.
Non ci sono animali, vero?
No, no, nell'acqua. Alghe, microorganismi. Nice. Bueno, we can, say bye-bye to the beautiful glacier, to the beautiful monster. We cross fingers for volcanoes on the way back. It's really calm now, it's beautiful. Ah, dormite qua, tipo